Good day, class. I am Ma'am Mary Queenie Velasco and I'll be your teacher for today. Last time, we have learned about organic compounds, its general classes, and its uses. Today, we will still learn about chemistry to deepen our knowledge about composition of solutions. In our present situation during the pandemic, taking vitamins and storing medicine is vital to ensure our health and to prevent diseases. Medicines are chemicals or compounds that help cure, halt or prevent diseases, ease symptoms, or help in the diagnosis of any sickness. But how do we measure the rightful amount of medicine that we need? And how do we measure the small entities that are found in our medicine? Today, we will all learn this using the concept of mole. To start and better understand our lesson, observe and analyze the given pictures. This idea of using different conversion units of measurement in selling and buying food ingredients and vegetables are also used by scientists in measuring the number of particles in a specific measurement known as mole. A mole is unit of measurement, equivalent to Avogadro's number, which is 6.022 times 10 to the 23rd power, which is the number of particles in 1 mole. This concept goes the same with what we see in this table. The unit of measurement and its equivalent value. 1 sack of rice is equals to 50 kilograms. 1 dozen of eggs is equal to 12 pieces. And 1 mole of water is equal to 6.022 times 10 to the 23rd power. Number of particles, atom, or molecules. The number 6.022 times 10 to the 23rd power is derived from the exact number of atoms in a 12-gram carbon-12. To help us understand how to use mole, let's try this analogy. 1 mole of anything is always 6.022 times 10 to the 23rd power. This means that 2 moles of anything is always 12.044 times 10 to the 23rd power number of particles. And 3 moles of anything is always, that's right, 18.066 times 10 to the 23rd power number of particles. Let's use this example. How many molecules are there in 4 moles of carbon dioxide? Let's remember that 1 mole is equals to 6.022 times 10 to the 23rd power number of particles. Thus, we will be able to convert the number of moles to the equivalent value or number of particles using this equation. Number of moles of carbon dioxide multiplied by the Avogadro's number divided by 1 mole of carbon dioxide. And here's the solution. 4 moles of carbon dioxide times 6.022 times 10 to the 23rd number of molecules of carbon dioxide divided by 1 mole of carbon dioxide is equals to 24.088 times 10 to the 23rd power number of molecules in carbon dioxide. Now, let's take a look on the step-by-step procedure on how to calculate moles and number of atoms. For example, compute both the number of moles and the number of atoms in 10 grams of aluminum. The mass of 1 mole of aluminum is 26.98 grams. Note, you can get this atomic mass of aluminum in the periodic table of elements. We calculate the number of moles of aluminum atoms in 10 grams by using the equivalent statement. 1 mole of aluminum is equals to 26.98 grams of aluminum. Here's the solution to get the number of moles. 10 grams of aluminum times 1 mole of aluminum divided by 26.98 grams of aluminum is equals to 0.371 mole of aluminum. Next, we will convert from moles to the number of atoms. 0.371 moles of aluminum times 6.022 times 10 to the 23rd power number of aluminum atoms divided by 1 mole of aluminum is equals to 2.23 times 10 to the 23rd power number of aluminum atoms. Therefore, the answer is there is 0.371 moles and 2.23 times 10 to the 23rd power number of atoms that is in 10 grams of aluminum. Now, it's your turn. Here's your learning task number 1. Answer the following question. Number 1. How many mango seeds are equal to 3.50 moles of mango seeds? Number 2. How many bananas are equal to 7.50 moles of bananas? Number 3. How many moles of rice grains are equal to 1.807 times 10 to the 24th power grains of rice? Next, let's learn how to calculate for molar mass of a compound. The mass of 1 mole of methane, or CH4, can be computed by adding the masses of both carbon and hydrogen. To solve this, let's first find out the number of moles per element. There are the element carbon and hydrogen in this compound. There is 1 mole of carbon and 4 moles of hydrogen. Next, let's learn their atomic mass. We can find this in the periodic table. The atomic mass of carbon is 12.01 grams per mole, and the atomic mass of hydrogen is 1.008 grams per mole. Now, let's multiply the number of moles times the number of atomic mass. In carbon, 1 times 12.01 grams per mole is equals to 12.01 grams per mole. And for hydrogen, 4 times 1.008 grams per mole is equals to 4.032 grams per mole. After getting the atomic mass of both elements, let's compute for the molar mass by adding their atomic mass. The atomic mass of carbon, that is 12.01 grams per mole, is added to the atomic mass of hydrogen, which is 4.032 grams per mole. Therefore, the molar mass of methane is 16.04 grams per mole. It's time to check your knowledge. Solve the following question. Number 1. If 1 mole of gold is equivalent to 196.97 grams, calculate the following. A. Number of moles in a 95-gram sample of a gold nugget. B. Number of atoms in a 95-gram sample of a gold nugget. Number 2. During exercise, lactic acid or CH3H6O3 forms in the muscle, causing muscle cramp. If 5 grams of lactic acid concentrate in your leg muscles, how many molecules of lactic acid are causing your pain? There are 12.0 gram per mole in carbon. In hydrogen, there is 1.008 gram per mole. For oxygen, there is 16 gram per mole. Now you have learned how to compute for the number of moles and atoms and get the atomic number, as well as how to compute for the molar mass. Why do we use mole? This idea helped a lot of scientists to measure the mass and particles in a substance. That's all for today. See you on the next lesson. Goodbye!